Good afternoon, folks. This video is intended to help us use our TI-Nspire to do some application of derivatives problems. This one happens to be similar to one we had on a test recently. Problem states number of bugs in a population is modeled by the formula P of t equals 1000 t over the quantity 10 plus t squared, where t is in hours. We are asked to find the time it takes for the population to be a max and the maximum size of the population to the nearest bug. So we're going to go ahead and use the TI-Nspire to help us out with this. We're going to start by creating a new document, adding a calculator page. Once I've added a calculator page, I'm going to go ahead and enter our function. Population as a function of time is equal to, now we have to use this special equal sign when we name a function. So I'm going to go control special equal sign. Now I need to enter the function. And that function was 1000 t over the quantity 10 plus t squared. Once I hit enter, I've stored that function into the calculator's memory. The next thing we need to do is we need the first derivative of this population function. That way we can use the first derivative test to find out when it's a max or min. So I'm going to again have the calculator do all the work for this. I'm going to call this, we'll call it P prime of t equals, and I'm going to take the first derivative with respect to time of P of t. Okay, so the calculator has now stored the first derivative of P of t in memory. Next thing we need to recognize is that now we need to start using a little calculus. We need to recognize that the first derivative will equal 0 at either a min or, well, the first derivative will equal 0 when the slope of the tangent to the original population function is 0. That could be a min, it could be a max, or it could be neither. So we're going to have to find out first where that slope equals 0, and then find out if it's a min, max, or neither. In order to find out where the first derivative equals 0, I'm going to have my calculator solve the problem. First derivative equals 0. So I'm going to go to the algebra menu, hit select solve, and I'm going to say solve the following equation. P prime of t equals 0, comma, t. So now I'm telling it what value I'm solving for. I get the answer negative root 10 or positive root 10. Well, one of these answers doesn't make any sense, and that's negative root 10 because we're not talking about going back in time. But positive root 10 does make sense. So that's now a candidate for me to test to see if that's a relative max or min or neither. So I'm going to come back over here to my worksheet, and I'm going to try and label this number line here. I know that P prime of t equals 0 at square root of 10. So I'm going to go ahead and label my sign chart with root 10. And that's the first derivative equals 0 at t equals root 10. Well, now in order to determine if that's a max or min, I need to test points over here and over here. I can use my TI-Nspire to do that. I'm going to test the first derivative at a couple points. Let's test it at square root of 9. It'll be less than the square root of 10. And that's a positive number, 2.77. So I'm going to add that positive number to my sign chart. And now I'm going to test a value greater than root 10. Test square root of 11. That's a negative value. So I'm going to add that to my sign chart. So my first derivative function is positive before root 10, it's negative after root 10. That means this is an absolute max because my population function is increasing and then decreasing. So root 10 must be an absolute max for my population function. So what that means for us is that we have P max occurs at t equals root 10. Okay, so the max population occurs at t equals root 10. Now root 10 isn't a very nice number in terms of talking about time. So let's go ahead and evaluate the square root of 10 as a decimal. In order to do that, I can either hit Control Enter to give me the approximate value, or I can just enter a decimal point anywhere in the problem. So I have root 10 is about 3.16, and that means I have about 3.16 hours to get to the maximum in this population. Now we're asked for the maximum size of the population to the nearest bug. In order to do that, I need to go back to my population function and evaluate it when t equals root 10. I can do that easily on my calculator by saying go back to my population function and evaluate it at the square root of 10. Now, when I hit enter, it's going to give me an exact answer, 50 times the square root of 10. But I'd really like to know, I don't know what that means in terms of a quantity of bugs. So I'd like an approximate answer. And I get 158.1. So to the nearest bug, we have P max equals 158 bugs. Hope this helps you learn a little bit more about your TI-Nspire calculator.